Hi, I'm Mr. Evans, and today's video is going to focus on kinetic energy. Kinetic energy, unlike potential, is the energy due to motion. Now, similar to potential, in my last video I mentioned that, sometimes I picture how much energy something has as its, potential to hurt me. Well, kinetic energy is now me picturing its ability to actually hurt me. And so for kinetic energy, energy due to motion. And so, if a car is driving across the ground, wow, I need to find out a way to get better pictures in here. That's my car. So if a car, or it looks almost more like a truck, I don't know, is driving across the ground, it has kinetic energy. If a plane is flying in the sky, it has kinetic energy. And something I want to point out that I think a lot of people forget is the plane has kinetic energy and potential energy, right? It is off the ground. And so it actually has both. Same with if, a baseball pitcher here is pitching and throws that fastball 95 miles per hour, the ball has kinetic energy. It's moving really fast. The ball also has potential energy. It's off the ground. All this energy is based on just two things. And those two things that it's based on is mass and velocity. And so knowing that, we can talk about our kinetic energy equation. And so kinetic energy equals 1/2 mv squared. Now, similar to before, mass will be in kilograms, velocity will be in meters per second. So yes, if you thought we were completely done with velocity and acceleration, we are not. In fact, I might have you have to solve for velocity, so then you can plug it into our kinetic energy equation. Okay, so with this in mind, let's go ahead and do a couple practice problems here, because there's some common mistakes I'd also like to point out with the kinetic energy equation. So I'm going to go ahead and write my equation over here. Kinetic energy equals 1/2 mv squared, and now I'm going to write our question off to the right. Okay, so let's say I'm out for a run. I have a mass of approximately 57 kilograms, and I am running at 6 meters a second. And I want to know what is the amount of kinetic energy I have. So, similar to our potential energy one, the very first thing I want you to do is see if we're in the correct units. And so I have mass, and we're at kilograms. Perfect. I have a velocity, and I am at 6 meters per second. Both are in the correct units, which means at this point it is plug and chug. And so we're solving for kinetic energy, and so I will come over to the right, and we have kinetic energy equals 1/2. My mass, I said, was 57, and my velocity was 6. Now, this next part is where people tend, if you're going to mess up on the math part, this is where you're going to mess up on. And what that is you'll see the exponent here. This exponent only applies to our velocity number and must be done first if possible. So right now I have 6 squared, so I'm going to go ahead and solve for 6 squared. And so I have kinetic energy equals 1/2 57 times 36, right? Because 6 squared is 36. From there I just multiply them straight across, so I do 1/2 times 57 times 36, and my kinetic energy is 1026 joules. And so because of my mass, because of my velocity, that's how much energy I have. So let's go ahead and get another example in here. And this time, let's actually have to solve for velocity. And so I'm going to make an equation here where I actually give you energy and mass, and we're solving for the other unknown. Okay, so my new question is, we have a 10 kilogram ball, which is a crazy heavy ball, so it must be a medicine ball, has 500 joules of kinetic energy. What is its velocity? So, I'm going to come over here. Well, actually, first up, as always, is let's check if we have all the correct units. So I have 10 kilograms. Kilograms is good. I have 500 joules. Joules is good. And so now I can start plugging numbers in. So KE is 500 equals 1/2. M is 10 and we do not know V, and so that is our unknown. And so again, this is where, if people are going to mess up, it always has to do with that exponent. Right now we can't do anything with it. It's attached to an unknown, and we do not have an answer for that. So I'm going to do 500 equals 5v squared, and so all I did there was the 1/2 times 10. And now I have to get the 5 to the other side, right? I'm trying to get the v by itself, so I divide by 5, divide by 5, and so now I have 100 equals v squared. So again, this final step, we have to do the opposite of the exponent, and in this case what I'm doing is I am going to square root it to get rid of that squared that's on the v. And so if I square root both, I get 10 equals v. And so that is 10 meters per second. And so our ball is rolling or has been thrown at 10 meters per second. So the last thing I want to point out, I won't do any practice problems with it just for the sake of not spending more time. But, the first step I always do is check if we're in the correct units. You cannot do the math problem and then convert the units later. And so, in this question, it worked out fine, right? I had joules and I had kilograms. But keep in mind, I can give you a question that maybe is in miles per hour, and you have to convert that to meters per second, right? Or I give you an object that's in grams, and you have to convert that to kilograms. So those are all things to think about. So, that's our video on kinetic energy. Hopefully it's helpful. And next we're going to move on to transfer of energy, because energy does not just stay in one form, it will switch forms.